Now we see this is a 2-frequency cube, but let's say we're going to consider this, as I showed, that this can be also a 72 block cube. The conversion number is not a big mystery, it's 1.5. In other words, 48 times 1.5 is 72. If I have a 16 block regular tetrahedron times 1.5 equals 24. If I have a 48, if I have a 96 blocks rhombic dodecahedron, Synergetics has 144, which is again 96 times 1.5 is 144. So that is our conversion number. But here I want to show something. We have a cube here, 72 blocks, and a cube, other cube here. This is called a body-centered cube. So we see that we are talking about the same cubes. What's going on in here? Like that. We have two cubes. Now this one is body-centered. It's made up of half couplers. They're like half octahedrons. But now let's go back. So we're going to show that the rhombic dodecahedron is the same animal. Here we go. Now this in a part like that. But anyway, here it is. So we put that. This is called inside out or elevated cube. So we're going to put these on the top of our cube. Oh, I didn't want this to come out like that. Gosh. Now I am all messed up. I hate this. Okay. Alright. Cool. You like that?
Yeah, it's cool.
Alright.
Was it hard to learn this?
Yeah, very difficult. It was very difficult to do.
Seems so simple, but I guess when while you're watching it, it's simple, but I guess when you're actually doing it, it's hard.
There is only really few rules. There is not that many rules, really. You just connect it, same colors. That's why this is good for visually impaired, because they don't see, but they can sense that. Well, anyway, we have this, man, it fell apart the way I didn't run it. So I have to start all over.
No.
Well, no, I have to build this. I know we don't want to start all over. You watching this camera?
Yes. How many times we got? I'm watching this.
How many times what? Are you going to say that?
No.
What are you saying?
I was saying how many
what?
how many times you're gonna have to build that little crown?
Well, I'm just trying to show that it's same relations and same modules, and there are no differences and no mysteries like we have found in Synergetics. Besides that, I'm gonna show something else very soon.
Are you watching this, Frank Zewett?
Yep. There you go.
Alright.
Oh, come on. Some of these magnets are not that strong. But anyway, here we are rhombic dodecahedron.
Oh, cool.
So it's built up inside out cube. Anyway, of course, I wish we can't do that right now, but let's go back in here. Halfway at least. I want to show something in here. Stop it for a second. Now we showed earlier how a concentric magnitude of solids ends with the rhombic dodecahedron, and now I want to show something that we are on the same platform with Synergetics, because we're going to measure the sphere radius. Now check this out. This is a rhombic dodecahedron, and it splits into half, and this is the other side of the cube. Goes like that, and I just want to show the cross sections. You guys see that the cross section is the edge of the regular tetrahedron, which is a radius of two spheres, which is a prime vector. And there is two of those. In other words, there is a sphere in the center. As a by the way, the 60 block cube octahedron in Synergetic is body-centered if it would exist, but it doesn't. They cannot build it, they're just talking about it. But anyway, that's the 2.5 volume regular tetrahedron. But here we see that this is the radius of two spheres, and then that would be the sphere which would enclose the cube octahedron, which would be on the inside of the rhombic dodecahedron, and these would be the touching points all around on the cube. That would be the cube face, I believe. Let's see. And then if we would want to enclose the how was this? I want to show this clearly. Now the sphere which encloses the rhombic dodecahedron would have edge 2, like the edge of the cube twice. You see it in here. And that would be the radius of a sphere which would enclose. Now, simply enough, the edge of this is 6.36. That is the radius of the sphere. You can calculate its volume, and we know we have to talk about the same spheres and same edge lengths, except that in Synergetics the prime vector is twice as long like this, and therefore the sphere they demonstrating that encloses the rhombic, that it encloses the cube octahedron is actually impossible. So the cube as in Synergetics, whose edge is square root of 2, the 72 block cube, then also cannot construct the duothet cube, because according to this demonstration I would have to need 576 blocks to do so. Since the elementary octahedron is 24 blocks, we would have to put that in a 2 frequency, that would be 196, and the 3 of those would be 576. So basically the star David of Star of David and the duothet cube build on it, it's impossible. And I want to finish showing one of the big advantages of the cube and the tetrahedron. If you want to use this as a volume unit, it's not very practical, because if I tell you that the edge of this cube is 3, we right away can know that the face is going to be 9 and the volume going to be 27. If I told you the edge of this is 3, and I even would give you the true height, 2 dimensions instead of 1, you still not be able to tell quickly what is its volume or surface area. Thank you, and I see you next time.
Boom happiness, boom happiness.